Now we look into the big picture of the quality assurance workflow. I have collected some examples of how these quality assurance workflows can be organized in software projects. First example comes from Eclipse blog. So let's assume that there is a developer that wants to implement the feature. So first what they do is that they take the master branch or the trunk and they clone it to their own computer. Then under their own version control they implement feature X. Once this feature is complete, they push it for review under the review system. Here the reviewers fetch the patch from the review system and look at the differences, just like the differences we saw on the previous video. Then they rate and comment on the patches, and the developer gets feedback. And if the feedback is not good, I mean it's bad, it means that the developer has to work on the feature again and push for another review, and then for another patch review happens. And then this cycle from 3, 4, 5, 6, and then it can go back to 3 or actually 2, where you develop the feature more. And okay, so finally when this is accepted, then it is put to continuous integration. And continuous integration is a system that builds the entire system, runs tests, runs static analysis, and provides back the result. And if the result is good, or if the result is bad, it can still go back to here, to the developer. But if the result is good, it is merged back to the main branch. This is how this quality assurance workflow operates. Another possibility for making the changes is that when one pushes for review, there is a simultaneous build in the continuous integration, and the static quality assurance and the tests are executed, and this provides a score. But at the same time, the reviewers are added and notified, and they start to perform the review. And if these 3 and 5 produce a positive rule, then the changes are submitted and merged to the main branch. If it's bad, really bad, then the change is abandoned and you start over. Then there is a branch here for rebasing and rework, where you only make minor changes and you start over. If it's abandoned, the idea, I guess, it's that you don't work on that at all anymore. You really start from scratch. So the difference to here, to the previous, is that here at the same time you notify the reviewers and you start building it in a continuous integration. Whereas in here it went first to the review. But you can also do it the other way around. So in here you fetch again the source code, or the clone source code from the repository. You modify code, commits locally, and push changes for review. Now it goes for review, but it actually starts with this Jenkins continuous integration machine that verifies the build. So the Jenkins verifies the build by running the unit integration tests and makes the deployment and makes sure that everything works. You can configure what the Jenkins does in different ways. You can include various static analysis tools there as well, and you can, depending on how it's configured and how many automated tests, this can take a long time or a short time. Anyway, so once this verification is complete, now there is a result that, okay, this builds and the tests are good. Only then is the review executed. So then it's fetched for review. If this Jenkins part fails, then it goes back to the developer. This organization has the benefit that the reviewer does not have to review anything that already fails in the automated quality assurance part. So if the tests fail, this reviewer does not even get started with it. Whereas in here it could be the case that the reviewer works on something that will fail, where the tests will fail later. So this reduces the human effort and puts more effort to the machine. And here is yet another version of the quality assurance. So again, the developer starts to work on something and fetches it from the repository. once the developer here is done, it pushes the changes. And we can see that it actually makes a separate branch here. So it doesn't go to the trunk, but it goes to a separate branch. And in this separate branch, these quality assurance activities happen. So first, the sort of auto review by Jenkins, test automation, also perhaps SonarQube like it's marked here. If it fails, back to the developer. Next, it goes to team review. If the team agrees that this is good, or if the team disagrees that this is good, back to the developer. So more work. Okay, if the team agrees that this is good, then it goes to the merge phase, and they have added here a delivery architect that can still put it back to the developer. So there is like a two-stage review. There's a development team that first reviews, and then even some delivery architects on the bottom after that. Okay, and after the delivery architect approves, you make a merge. So then another round of Jenkins and SonarQube, because there might be more changes here already. So there is a new version already coming back to the trunk here. So the Jenkins and SonarQube done in here only validates this branch, but going back to here, it needs to be revalidated. So Jenkins and SonarQube again, if it's not okay, I guess back to the developer or maybe to some other persons in Pro. Okay, if it works, then it goes to deployment, automated testing, and integration. And then there might be functional tester, some person that manually executes the test. And then, it goes to the client and goes to Nexus for binary version control. So one can organize the quality assurance workflow in multiple different ways. The idea always is that there is some quality checks on the source code that is submitted to the trunk, and nothing is accepted in the trunk unless it passes some of these quality gates: automated tests, automated static analysis, code review. The number and thoroughness of these quality checks, of course, can be very different between different projects. If very high quality is required, then more checks will be done than in a project where the quality is not so great concern.